Okay, when it comes to astronomy, 2026 can now be officially referred to as the year of maps. Because in some sense, we've officially reached the golden age of cosmic mapping, as we've just had two massive releases from two completely different surveys, revealing the universe in a way we've never seen it before. But that's on top of additional surveys that are going to be released very soon, and even more surveys starting in the next few months. And so, hello wonderful person, this is Anton. And well, today we're going to talk about some of these maps, but also discuss how they actually sort of helped us redefine our understanding of the universe, and how a lot of things we knew about the universe fundamentally changed in the last few years. For example, various ideas behind dark energy, or how the universe is expanding and what it's made out of, have now been sort of challenged by some of these new discoveries. With many of these new surveys and new maps not just showing us actual galaxies, but even revealing the very skeleton the universe is made out of, and even showing us that the ultimate fate of the universe might be just a little bit different. And so let's talk about some of the main discoveries from these two extremely large maps, and of course talk about why this matters for the future of science. And let's start with the most recent and perhaps the most significant breakthrough. In April of 2026, DESI, or Dark Energy Spectroscopic Instrument, has finally completed its primary 5-year survey, but in this case just a little bit ahead of schedule. And well, here we had something absolutely incredible. Located on a mountaintop in Arizona, this particular survey used a very specific instrument that's actually a kind of a technological marvel. It essentially uses 5,000 robotic fiber optic eyes that can individually swivel to point at distant galaxies, and they do so with extreme precision equivalent to a thickness of human hair. Each of them kinda looks like this, and they're actually referred to as fiber positioning robots. And so here, by using 5,000 of these, this project has now produced the largest high-resolution 3D map of the universe ever made. This is essentially what you're seeing here. And to give you an idea of the scale, here DESI has mapped over 47 million galaxies and quasars, along with 20 million stars in the Milky Way galaxy. And this is at least 6 times larger than all of the previous surveys combined. Now obviously this is still a far cry from over 1 trillion galaxies we think are out there in the observable universe, but at this point this is the largest we have. And so by looking at these millions of points of light, some of which are at least 11 billion light years away from us, it allows researchers to actually see how the universe developed and how it changed in the last 11 billion years. So not its entire history, but most of the history. But I guess the question is, why do we even need this map? Well, here the name itself explains why. The main goal is to try to understand the mysterious dark energy, the unusual force that seems to make up about 70% of the entire universe, and that's basically causing the universe to accelerate its expansion. And well, as we've discussed in some of the previous videos, for many decades it was always assumed that this expansion, defined by the cosmological constant, is basically constant, as in it seems to stay forever, and the universe has been expanding faster and faster at the same rate. But a lot of the early results from DESI, especially the ones from last year, have already provided a major hint. Dark energy might be actually evolving or changing over time, because otherwise these observations would not make sense. You can learn about this in one of the videos in the description. But by having this new release, and by having a complete set of 47 million galaxies, researchers are now trying to figure out if this is going to confirm this initial discovery, or possibly disprove it, explaining why the initial results were so different. And so if this is actually confirmed, which will probably happen sometimes next year in 2027, the result in this case would be revolutionary. It would actually very likely completely redefine our understanding of the universe, and would basically require rewriting of the current models in cosmology. Or basically this would give us a direct hint that the current laws of physics seem to be incomplete. And here this is not just a small detail, because in this case this also affects the fate of the universe, or basically how we think the universe will end one day. And though previously it was assumed that it's going to expand forever, now there is actually a hint that one day it might collapse, or might even end up in something else entirely. And so here, depending on whether the dark energy idea is a constant or not a constant, kind of changes everything. But right now we don't really have any additional answers, and instead just have this very beautiful 3-dimensional map. We'll definitely discuss this in some of the future videos though, because here the suspense is getting really intense. But anyway, let's talk about something else. And that's because while DESI looks at the visible light, there are other surveys, and actually extremely large surveys, that focus on other wavelengths. And specifically, the survey referred to as LOFAR, or Low Frequency Array, has now mapped the universe using radio waves, with the final release being done on February of 2026. And in this case, this map contains 13.7 million cosmic sources, many of which have never been seen before. And in this case, radio maps, unlike optical maps, show us a kind of a hidden side of the universe. So basically, instead of seeing stars and possibly galaxies, we're seeing high-energy events. And in most cases, events involving really massive, growing black holes. And so here, this map is the most complete census we have of active growing supermassive black holes in a certain part of the night skies. And a lot of these black holes blast out massive jets, usually involving fast-moving particles that can sometimes extend for millions of light years. This is kind of what you're seeing in this image. And in this case, this particular survey now covers 88% of the northern sky and is based on almost 11 years of observations and 13,000 hours in total. Although, as you can see from this map, this is not just a single telescope. This is basically a network. It involves 8 countries and is technically one of the most successful international scientific cooperations on the entire planet. And though right now this was just released, so there are no studies analyzing any of these objects, in the next few months we're going to be seeing a lot of studies on the evolution of supermassive black holes, the analysis of galactic clusters, mostly investigating the so-called intra-cluster gas, or the gas between galaxies, but also studies on star formation and especially understanding star-forming regions during different periods of the universe. But here, at least some of the emissions are also mysterious transients, and specifically either pulsars or neutron stars, or possibly even emissions from various planets in the vicinity of the solar system. Right now we don't actually know exactly what some of these sources are, but in time we will. And lastly, one of the most important parts of this analysis is actually in regards to the magnetic fields, and specifically Milky Way's magnetic fields, which have now been mapped with unprecedented accuracy, which will obviously help scientists figure out what's happening in the Milky Way and how the galaxy is evolving. But for the exoplanetary studies, one of the most exciting and potentially one of the most interesting discoveries seems to be the detection of radio signals consistent with magnetic interactions between stars and exoplanets. And for exoplanetary studies, this is really important because we can use these emissions and these radio signals to study the environment around planets and to even study their weather. But once again, this is something that has not been done yet. Okay, cool. But I guess the question is, so what's next? Well, in order to understand if these maps are correct, in most cases scientists will have to compare these to various simulations and theories. For example, one of the newer simulations, Sibelius Dark, tried to recreate a kind of a digital twin of our side of the universe within approximately 600 million light years of Earth. And this of course involved simulating laws of physics with unprecedented detail. And so the next step in this case would be comparing this with what we actually found. Now, based on some of the previous reports from DESI, there was actually a match, but this was based on an older release. And so now scientists will have to do the same, but with this new data and these new maps. Interestingly though, even back then this simulation accurately predicted the location of the Virga, Coma, and Perseus clusters, and even recreated virtual versions of the Milky Way and the Andromeda. In other words, at least when it comes to some of these simulations, they're to some extent somewhat correct. Which of course also suggests that the standard model of physics, or the lambda CDM model, is still sort of on the right track. But nevertheless, it's really in the next few months that we're going to be learning how accurate all of this is, and how accurate these physical models truly are. For now, we just have these really cool maps, and a lot of data to go through. Which means that possibly by 2027, we might have certain answers on things like, for example, the overall mass of the universe, or basically by studying these galactic clusters, we might get better estimates on the overall mass of everything. It will also help us search for the mysterious dark matter, and give us the ultimate answer of where the universe is headed and what's going to happen at the end. Is the universe going to continuously expand? Is it going to stop and start shrinking? And is the universe cyclical and repeats over and over? Or is it just going to end? Although, just so that we're clear, for most of these projects, including DESI, the work is not finished yet. As a matter of fact, DESI has already been extended to 2028, which means that it's going to create an even larger map, which scientists never planned to make. And its new focus is going to be on classes of objects referred to as luminous red galaxies, extremely faint and very distant galaxies that we actually know very little about. Whereas when it comes to LOFAR, it's now also been upgraded to LOFAR 2.0, which doubled its speed and its sensitivity, making future surveys much easier. And for astronomy, it means that we're now going through a kind of a transition where we actually used to study just individual objects, but now it's all becoming more statistical, or we're basically entering the era of statistical astronomy. Here, we need to study millions of objects in order to work out the overall patterns, which is why a lot of these projects involve so many researchers. DESI alone had approximately 900 researchers from 70 independent institutions. And so once again, these are extremely successful scientific collaborations that will hopefully only grow in size. But on that note, I'll just end here because there are no discoveries or conclusions yet. Thank you for watching, come back tomorrow to learn something else, support this channel on Patreon where you can find additional videos without any ads and can DM me directly, or by joining a channel membership that grants you early access. You can also support this channel by buying the Wonderful Person t-shirt in the description below. Stay wonderful, I'll see you tomorrow, and as always, bye bye.